Welcome back to Wildcat Academy. Today we're going to be exploring the Triangle Midsegment Theorem. So the Triangle Midsegment Theorem states if a segment connects the midpoints of two sides of a triangle, then the segment is parallel to the third side of the triangle and also half its length. So the first thing we want to do is how do we recognize when we have a midsegment? So you'll see in our example here we can recognize D as a midpoint because AD is marked congruent to DB, and point E is marked as a midpoint because segment AE is congruent to segment EC. That meets the definition of a midsegment, and a midsegment is the segment that connects two midpoints of the side of a triangle. And that then leads us to meaning once we've met the hypothesis, we know that the conclusions are true, is that DE, segment DE, or the length of DE, is 1/2 the length of segment BC. Or you could even say that segment BC is twice the length of segment DE. And we also know that, so that's one part of the conclusion. The other part of the conclusion is that line segment DE is parallel to BC. So if we're given that a segment is a midsegment, then we would be able to know that DE is parallel to BC, and that also some relationship such as like if DE was 5, then BC would be 10. Okay, so as we look at this problem, we have some algebra representing segment DE, 2x plus 7, and we have the number 30, the length of 30, representing the segment BC. And we can use either one of our equations for the relationship between segment DE and the third side of the triangle BC. Using the second one typically ends up being easier because we avoid the use of the fraction 1/2, but you can substitute into either one and they work just fine. So 2 times the 2x plus 7 is equal to 30. That gives us 4x plus 14 is equal to 30. And then 4x is equal to 16. Divide by 4, we get x is equal to 4. And we could substitute back in there, just a quick check. This length should be 15, so 2x plus 7. 2 times 4 is 8, plus 7 is 15, as it should be. And just a quick little side note here, you can see that when you have all three midsegments drawn in, as we do in this example here, you can see that these segments end up being congruent to one another. So this length is 15, this length is 15, and this one is also 15. All right, so jumping into, that explains a typical question on, finding missing side lengths. So the second part of our conclusion in the Triangle Midsegment Theorem states that we end up with DE parallel to segment BC. This parallel lines create corresponding angles inside of a triangle. They will also create same side interior angles here. So some very simple relationships there. So if this length is 40, that means this length down here is 40 because those are corresponding angles, and corresponding angles are congruent. We can also see that if this angle here was 100, then angle C will be supplementary because these are same side interior angles. And that really breaks down the typical two relationships that were created from a triangle midsegment. You can also go back up here and find the third vertex of the larger triangle, 180 minus 40 minus 80, and get that angle to be 60 degrees. All right, so what would that look like with some algebra? So you have two same situations here. We have algebra representing the corresponding angles this time. So we will solve for x in this problem by setting the measure of angle ADE equal to the measure of angle B. So setting 2x plus 15 equal to 4x minus 25. And then we'll do the algebra necessary to solve this. We're going to subtract 2x over here And we're going to add 25 to this side, canceling it on the right-hand side. And we'll end up with 2x is equal to 40. Divide both sides by 2, we get x is equal to 20. And then if we wanted the measure of the angle, this problem didn't ask for it, but we could substitute that in, and we could find that the measure of both of these angles would be 4 times 20 minus 25, that's 80 minus 25. Looks to be 55 degrees and 55 degrees. And we plug in 20 to both examples, and that ends up working out. But we're also asked to find the value of y. Well, the relationship between these two angles, because we have parallel lines, we have the same side interior angles theorem, or the consecutive interior angles theorem, which tells us that these two angles must be supplementary. So we can add those two angles to be 180 degrees. And then we simplify the left-hand side expression, get 9y plus 18 is equal to 180. We'll get 9y is equal to 162. Divide by 9, and believe we get 18. And then we can go back and we could substitute back in again if we were asked to. We're not asked to on this problem, but we can check our work very quickly by doing that. 5 times 18 plus 8, that gives us 90 plus 8, which is 98. We can multiply in here. 4 times 18 plus 10, that's 70. So when we substitute in 4 times 18 plus 10 into this angle, we will get the measure to be 72. And remember that these, unlike our first two angles, which were corresponding, they were congruent, so we ended up with the same value. Here, when we substitute in, we should get supplementary angles, and 72 plus 98 is 180 degrees, and therefore we have something that fits with the parallel lines, and these being consecutive interior angles. So you could go back and find the measure of angle A here. Again, that would be an extended problem or a different problem, but some problems might ask you to do that. Finding 180 minus 98 minus 53 would give you a measure of 27 degrees for the measure of angle A. But in this particular problem, we are only asked to find the measure of angle, or the value of angle X and the value of angle Y. All right, so those are more applied problems, calculation problems of finding direct values of X and Y, angle measures, side length measures, but we also have the impact of this theorem on proofs. If you found this video helpful, be sure to like and subscribe to the channel, and look out for more great videos from Wildcat Academy.